Hi friends, today we're integrating ArcCosx. So the first thing we need to do is know that 1 times ArcCosx is equivalent to ArcCosx. So we're going to do integration by parts since it's a multiplication. Let's go ahead and label the different components. The integration by parts is VU minus the integration of V du. So let's go ahead and label components. So we have U, du, then we have V, and then we have dV. So we're gonna put our cosine as U and 1 as dV. So V is equal to the integration of 1 dx, which is just x. Now we need to derive arc cosine x. So let's go ahead and do that on the bottom and come back later. So we got arc cosine x is equal to y. So we're going to use implicit differentiation. So let's go ahead and put cosine on both sides. So we got cosine, arc cosine x is equal to cosine y. So this cancels. So I got 1 cosine y. We're going to differentiate both sides. So we got 1 is equal to negative sine y. Since it's implicit differentiation, you put dy dx for all the y's. So we're going to divide both sides by negative sine y. So we're going to isolate dy dx. So these cancel. 1 over sine y is equal to dy dx. Now we need to use a trig identity, which is cosine squared y plus sine squared y is equal to 1. So we're going to isolate sine y. So we're going to subtract cosine squared y on both sides. This goes away. And then we're going to square root both sides from there. So this goes away as well. So we have sine y is equal to the square root of 1 minus cosine squared y. As you can see, that x is equal to cosine y. So we're going to try to go back to x, which is very important. So we have sine y is equal to square root 1 minus x squared. So we're going to substitute this into here. So we have 1 over negative square root 1 minus x squared is equal to dy dx. So we're going to use this again. We're going to input this as our du value. So let's go ahead and go back up. We got 1 minus square root 1 minus x squared. Okay, let's go ahead and move all this to the bottom and work on the integration by parts. Let's copy it and let's go ahead and go to the bottom since we need more space. Okay, so let's put the value in. So we have x in the front here. Then we got arc cosine x. So we're inputting the values. So here's the value. I'm putting v with x and u with arc cosine x. Then we got minus the integration of v, which is x again. Here's x. And then you have du as 1 over negative square root 1 minus x squared dx. Let's put the negative in front. You're going to move this to the front. We could do that since it's a constant. So we have x arc cosine x plus the integration of x over the square root of 1 minus x squared dx. Now we need to use a u substitution. So we're going to put u as 1 minus x squared. And we're going to differentiate both sides. So we have du equal to negative 2x dx. And then we're going to divide both sides by negative 2x. This goes away. So, okay, let's go ahead and put that in here. So we got x on top over u, square root u. And we have du over 2x. So the x will cancel. And we have a constant, so we can move that to the front. We're going to go ahead and put the u as u negative 1/2. Because a square root would be 1 over 2. It says it's in the denominator. When you move it up to the numerator, it's a negative power. So we have negative 1/2 in front, and we have du. So we're going to integrate u to the negative 1/2, which is 1 over 2 over 1/2. And we've got 1/2 in the front as well. So these actually cancels. So we end up with 1 minus x squared to the 1/2. So we can move this to the bottom. So we have x arc cosine x minus, so if we have this negative right here, which is going to the bottom. And then we could also make this into a square root if you like. It'd be the same value no matter what. But let's go ahead and do that. So x arc cosine x minus the square root of 1 minus x squared plus a constant. And that is it.